In this video, I'm going to help explain how to solve this problem here. We're given that a function equals f of x equals x squared minus 64, and we want to do two things. First, let's begin with finding the value of this function at 3. So that simply requires a direct substitution. So we're going to replace the x value with 3, raise that to the second power, and then subtract 64. Since 3 to the second power is equal to 9, subtracting that by 64, that gives us a difference of negative 55. So this is your solution and the value of f of 3. Now the second part is asking us to solve an equation. It's asking us to find the values of x that satisfy the condition where f of x equals to negative 63. So that requires us to solve an equation. And there's actually two options, two techniques we can apply. So option 1 is going to require using square roots. So if I get my function f of x, again, and set it equal to negative 63, which is x squared minus 64, that equals negative 63. I'm going to solve this by adding 64 to both sides, kind of like letters to the left, numbers to the right technique. So isolating the x squared, we end up with a value of 1 on the right side, and now we can simply take the square root to both sides. This is why it's called the square root technique, and we get that x equals to both positive and negative 1. So positive and negative 1, which you would have to write like this. You can use that symbol there, so you would have to simply separate it, and that right there would be your answer. Now there is a second technique that uses factorization. So this would use the square roots. And the second technique uses factorization, factors. So we have this is option 2. So we have our equation x squared minus 64 again equals negative 63. And in order to use factors, we set the quadratic equal to 0. So that means that we're going to move this to this side instead. So instead of adding 64 to both sides, we're going to add 63 to both sides. So we can get the right side equal to 0. This ends up equaling to x squared minus 1. And to factor this type of quadratic, what we have our leading term, x squared, and our constant is that we simply take the square root of both sides. So this is going to break out into x and x. The square root of x squared is x, and the square root of 1 is 1 and 1. And the sign of these factors inside here are going to be opposite. One will always be plus, the other one will be minus. And that's how you factor these type of examples, which, if you recall from Algebra 2, this is referred to as the difference of squares. So this is how you use the difference of squares and how you break apart or factor a difference of squares. Now, having this set equal to 0, then again, we just simply follow our rules for factors set equal to 0. In order for this equal to 0, it has to be the opposite of this value, which would be negative 1. And to make this factor equal to 0, it has to be the opposite of this, which is positive 1. And again, the same values as before. So you can use either of the two options to solve that second part, to find the values of x that will satisfy this scenario here, where f of x is going to equal to, in this scenario, negative 63. I hope this was helpful, and I appreciate you watching.